Okay, so we're gonna get started. In this discussion, we're gonna be talking about how to get set up with Google Test and how to use it. But before we do that, first question for you guys is, why do we bother testing? Make sure it works, right? How many of you guys have ever made a mistake when you were programming? How did you catch it? Right? You had to, test it to see if something went wrong. Testing is like a mixed bag and that it's not ideal because it doesn't verify that your code works, right? It doesn't verify that there are no bugs, that it's correct, that it's right. When you pass the test cases, even if you're passing mine, all it means is you pass those test cases. It doesn't guarantee that your code does work, but it doesn't guarantee that your code's correct. It just gives a stronger guarantee that it's probably not as wrong as you could be, right? So do keep that in mind when you're testing. If there's some bug, but you don't test for it, you're not gonna find it. So keep that in mind when you're developing your tests. But we're gonna be using Google Test in this class for a little bit of testing. Other question I have for you guys is, how many of you guys actually test your code when you're before you submit it versus just submit to Codathon and see what blah it spits back out? Okay, yeah, that's my fear every time I provide testing to you. You do want to get in the habit and in the practice of testing and verifying your own code, because that's a skill that you're going to need once you become like a programmer outside of school, right? When people aren't providing test stuff for you, you have to do your own. So get in the habit of testing your own code, debugging your own code, seeing if things are going to go wrong before you submit, right? Try out different possibilities of what could happen. Like I would expect, like for the last midterm, that you would have tested I went vertically somewhere, I went horizontally somewhere, I went diagonally, I went diagonally. I can test to see if a tie works correctly, right? You may also try to do some tests like in the middle of the board or the edges of the board that are likely to cause errors, right? Or because you might have like a one out of bounds mistake or something along those lines. So here's how you get set up with Google Test. There's a big, long, a lot of blah that you have to go and add to your cmakelist.txt to make it a part of your project. So first we need to find package threads. It's required. It's needed to build Google Test. Then we include fetch content. This is going to allow us to go download Google Test from online and bring it into our project. This next set is from the fetch content. So fetch content declare. We're declaring some new thing that we want to get. Its name is Google Test, right? This is where it lives out on the internet. And the tag that we want to get, which branch we want to pull from, is the master branch. Then we say fetch content get properties. This kind of gets the properties of Google Test and initializes them. So if we haven't already downloaded Google Test, well, we're going to need to go get that. So go get Google Test. Then we're going to go add the subdirectory for Google Test. It's source directory and it's binary directory. And I'm not sure. So we go and add this in. And then CLine complained, even though it shouldn't because of the linking that's going to be done later on. So you say target include directories, whatever the name of your executable happens to be. In this case, it's simple tests. Private, if you want Google Test, it's Google Test source dir, Google Test / include. And if you want to use gmock, which we're talking about next week, you include gmock. Then you link in your libraries, so your exe name, whatever that exe is going to be, private, gtest if you want gtest, gmock if you want gmock, gtest main if you're looking to use Google Test main and not your own provided main. Right, and this is all done as an example over here in simple tests, which is online, and you can see that we have all that stuff. Any questions about those set of commands besides copy and paste them in there? And the other thing is, for when you go and you're in CMake, you're gonna have to go put a setting on over here. So it's -d install gtest equals off, because we don't want to install gtest because we're building it as part of our project. So if you're looking to use Google Test, you include gtest/dtest.h. You want to use gmock/gmock.h. All of like the testing in Google Test revolves around like assert and expect statements. The difference between assert and expect is what happens when the value that you're asserting or expecting doesn't meet what you want it to be. So if they're both true on that assertion or expectation, great, the test passes. If you assert and the test fails, like the test stops, quotation marks. There's some issues about it stops, but it will fail a test. And then expect will make the test fail at the end, but the test will continue going on from there. So you use asserts where if this condition wasn't met, nothing else is going to work. You assert. If the condition failed, but you could still keep on going, then you would make an expect on that. Expects are generally more preferred than asserts because it allows you to catch more errors and more reporting. If you want to and you want to provide like a more detailed error message, you can stream into the assertion or expectation to provide that error message. Yeah. The assert would be inside the test itself. So here's an example of assertion and expectation, right? This might be inside of a test that's trying to check to see if two iterators have the same values. So, right, if they don't have the same size, well, we can't really go on from here. Something else went pretty bad, so just stop. Then we go through each one of the values, and we expect that x at I should be equal to y at I, right? But if multiple values are different, we're going to have all those reports of them being different. We won't just stop with the first difference. Any questions so far? Okay, so these are all the things that you can assert or expect, at least the basic ones. So you can assert that some value, some expression evaluates to true or false. You can assert that two values have to be equal to each other, not equal, less than, greater than, equal to, greater than, or equal to. And these ones would all call like the overloaded operators for that class. So if your class doesn't define like an equals equals, right, you can't do an assert equals. If your class doesn't define a less than, you can't assert a less than or equal to, or assert a less than. Does that make sense? There are also some things for C strings. And when you're working with Google Test, you probably really want to start out by reading this primer. So if you go to Google Test, if you Google Google Test, you'll find this primer here. And there are a list of basic assertions that we find here. So if you're working with C strings, you can assert that two strings are equal. Two C strings have the same content. You can assert that they're not equal. You can assert that they're equal regardless of case, right? And then this is assert equals or assert not equals regardless of case. So when you're creating test, the basic syntax is test, test suite name, test name, and then the code that you want to execute for that test. The test suite name is like the group that this test belongs to. So you might have something like constructor tests, right, where you test out the constructor of your class. Then you might have something like, insert tests, where you're testing out the insertion functionality of your class, or whatever it wants to be, but you might have multiple tests in that category. The particular name of that test is in test name. And then somewhere here inside this test code, you need to assert or have an expectation on that code so the test will succeed or fail. So here's an example of testing some function called factorial that it works correctly. So you want to test the factorial to see if it handles 0 input. So you call factorial with 0, expect this value should be 1. And then here, this one handles some positive input. So you try out your factorial with some values that you know to see if it's working correctly. One thing to note when you're doing your tests is that Google Tests can't test freestanding code that's outside of a namespace or of a class. So if you just have like, int my function and you want to test it with Google Test, it can't. It needs to be enclosed within the namespace. But if you have any code that belongs to a class, you can totally test that because it's inside the class's namespace. So here's an example of this. So over here, right, I made a class that just does the Fibonacci sequence, and it's called slowFib because it's implemented the bad way. But notice I had to put it inside of its namespace, which is called fibbing, so that it's going to work correctly. If I remove the namespace and just make it freestanding code, Google Test can't test it anymore. So over here, I have my implementation of the Fibonacci function. And then over here in test.cpp, I have my test. So, my base case 0, right? If I pass in 0, do I get 1? If I pass in 1, do I get 1? If I pass in 2, do I get 2? 3, 3, 4, 5, 5, 8. Right? So I'm just testing out a couple of different values to see if they work. And this is like a very simple function, so the code in here is not that complicated. We will also a little bit later on take a look at like the testing stuff that I've done for your homework to get a better idea of like what you can do. Are there any questions here? Then over here in main, if you want to build your own main, it's more or less going to look like this. There's also the option of using the built-in or like the packaged Google main if you want to, where you can just link in gtest main and it'll build that one instead. You can see here I'm not using this piece of code. I'm using the gtest main. So if we go ahead and we press play, builds, eventually. And you can see, oh, like we failed a whole bunch of tests, right? And on the test that it failed, it says, hey, when you called slowFib with 0, right, you got 0, but we expected it to be 1. So there's a mistake here. So we might pop back into our fibbing code, and if we look down, what might we notice is our problem? Given just based on this test, when I called slowFib with 0, the result that I got back was 0. So tracing this through, n equals 0, I said to return 0, but I should be returning 1. So we just would fix that, and then if life is good, when you run it, your output should look like this. Where it's happy and it passes all the tests. And then you can also, debug these tests. So if something doesn't work, throw on your debugger and then go inside of it and see what's going on. Sometimes you're going to find that you have a lot of code that you want to keep reusing. And so instead of like copying and pasting it everywhere, you could of course put it in a function and call those functions from inside your tests. Or you could put your code inside of a test fixture. And also if you find that your code is operating on a lot of similar data, you can put that data inside of a test fixture. Man, that's a hard word to say for some reason. And then have that test fixture do the common initialization stuff. So a test fixture is simply a class that inherits from testing : test. Members that you want to access, those common data members, should be either at the public or protected level to be able to access them. And then when you use a test fixture, the process of what happens during a test is first it's going to call that fixtures constructor. But unfortunately, the fixtures constructor always has to be the empty constructor. You can't pass any arguments to it. It won't be called. Then it calls the setup function. Then it's going to go run your code. Then it's going to go call the teardown function, which is supposed to undo the setup. And then it calls the destructor, which undoes the constructor. And for every single test that you have that uses this fixture, it creates a new fixture, a new instance of this class for it to work on. So what you might want to do if you declare a fixture is like you have public, you have class myFixture. We haven't talked about inheritance yet. We'll hit it next week. A colon, public, : testing, : test, protected or public, and then the members that you want to access inside here. You could also provide any methods, again, for like common pieces of code that you want to run. Could be in here as well. Google Test also gives an example of this. So for example, over here, they have a queue, right? So they want to see if they're able to put things at the front of the queue, remove people, or put things at the end of the queue, remove things from the front of their queue. So they have their class called queueTest. Normally what they do when they have their fixtures, they call them something test, whatever the class is that they're testing. Colon public, again, we inherit from testing colon test. Inside protected, they have setup, which is going to enqueue the value 1 into Q1, enqueue the value 2 and the value 3 into Q2. And then void tear down, right? They would do whatever they needed to in here to destroy the things, but they apparently don't need to, so they don't have it there. And then we have our members, Q0, Q1, and Q2. So now inside of your tests, when you have a test fixture, you have to use test underscore F instead of test. And then you put the name of your test fixture class, QTest in this case, and then again, the name of your test. So they expected that Q0's size is 0, right? They want to test that DQ works. So they do, Q0.DQ, and they expect it to be equal to the null pointer. That list was empty. Q1.DQ, they assert that it's not equal to the null pointer. They expected the first value to be equal to 1. Right, they put in 1 there. And then they expect it to be equal to, its size to be equal to 0, right? They expect it to be empty after you take out the one object that's there. And then they make sure to delete the thing that they've taken out. And then again, Q2, they full format twice. Does that make sense for the test fixture? Right, that's if you want to be able to reuse that data, reuse common pieces. Any questions so far before we keep going with this? Generally, it's preferred that you do your work in the constructor, but sometimes you'll need to do work in setup. Go follow that link for a more detailed explanation as to when you should use the constructor and when you have to use setup. Talked about test underscore F instead of just test. If you do test, it should complain at you. Some other things you might want to do are explicitly succeed or fail. Succeed, you just generate a success. You can't write to it. Fail, it'll generate a fatal failure, and you can put a message into it. Then you can add a failure at some location. It'll generate some non-fatal failure, and you can stream a message to it. So this is like kind of like the expect kind of type of failure that you can add. This is really useful if you want to test control logic instead of testing values, right? I want to make sure that I never go inside this if statement, right? I don't hit the else. So you can assert that there's a failure that could assert a failure inside that particular case. We'll talk about gmock next week. But one really useful thing from gmock that you can use inside your code are matchers. There's a full list of matchers here. But some things that you can test for are like, does a string start with some other string? So they have like equal, greater than, less than, equal to. Like those ones aren't super interesting. But you can do like string matchers. Does a string contain some regular expression? Does that regular expression appear inside? Does a string end with something? Does a string contain substring? Does it start with something? Is the cases, are they equal without cases? Right? You can also check to see if some container contains some value. Right? You can check to see if the elements inside your container are something. You can check to see that it's empty. You can check its size. You can check to see if the unordered elements are. So like these values have to appear inside the container, but I don't care what order they appear in, which is really nice. And the cool thing with these guys are that they can be matchers, so you can pass in other things. Like I want my, you could pass in like a matcher, like this thing has to be greater than or equal to 5. There must be something that's greater than or equal to 5, something that's less than 2. You put an underscore, it means it could be anything. And so you can put something fairly complicated in there if you're looking at your container. So these guys are super duper powerful and useful, and I kind of wish I knew about them before when I was writing all your test cases, because I probably could have used them. but it didn't, so that's what I'm stuck with. The other thing that you might be interested in is creating tests that have parameterized over the values, right? If we look back over here, it probably would have been nice where we could have just written like one version of the test and we could just throw it different values so that we could do like value-based testing. That is possible to do in Google Tests. It's in their advanced guide. So if you want to make something to be a value parameterized test, which we can try implementing in a second, you have to inherit from both testing and testing with param interface T, where T is the type of the parameters that you want to be able to pass in. Fortunately, it just has one type there. But instead of just deriving from both of these, you could just derive from testing, test with some parameter. T, again, being the parameter. So over here, right, they have some class foo test. It inherits from testing with param, and they're going to take in a const chart pointer. And so again, you write your tests now with test underscore p for parameterized instead of just normal test. And again, you list the name of your test fixture. And then when you're ready to create your test, you say instantiate test suite p, and then you give it the values that you want it to work on. So you can say like, I want to do a range, in being a list of values, which I guess like when you do range, it doesn't have to be number, right? If you had some class that defined the plus operator on it, then you could pass it in here. You could say it has to work with these values, the values that are in this container. Bool would be true or false, and then it would be combined, which would be as a values yields all combinations of the values generated by the end generators, which is these generators back here. So for example, if they wanted to instantiate their test suite with meany, miny, and mo, instantiate the instantiation name, which is just some extra parameter you have to provide, of foo test, testing : values, meany, miny, and mo. And then it's going to run it with instantiation name, which would be the prefix, because you need to be able to separate it with like the different types that you create. So instantiation name foo test does blah with meany, does blah with miny, mo, and so on. Again, looking at this now, it seems kind of harder to work with because like anyone that you would, all these tests that you instantiate have to use the exact same set of parameters. And then I believe to get the values, you have to do something funny. No, that's not useful. Anyway, maybe we'll talk about that, but I probably need to look over that again, so watch the next video, because I think it's kind of, you have to do something funny to get the values back out. I used it once in the past to get it out, but we'll pop over to the double linked list testing to see what's going on over there. And then we will come back. One other thing that I forgot to mention is you might have a function, right, that you call. And that function might assert something, or it might make an expectation. So let's say you called some function, and inside that function it calls an assert, right? And right, which is going to fail. Do you think the entire test would fail, or just that function would fail? So inside my test, I call foo. Foo calls assert. That assertion fails. Do you expect my test to be completed now at this point, or would you expect only foo to be completed? Test is completed. Foo is completed. I honestly would have expected that test was completed, but apparently it's not, right? And it's something that confuses people quite a bit. And so you can check to see if you call a function that it doesn't assert, which is here. I would recommend reading through the advanced one too. So what you'd have to do is when you call the function, you have to say like assert or expect no fatal failure. So this is so that's the example that they do here. So you would say like assert this function has no fatal failures. Like assert no fatal failure foo. So foo doesn't fail. The other thing is that you can only like assert in functions whose return type is void. Expectations can be in either one of them. Or you can say expect no fatal failure and then include a block statement, something inside some curly brackets that, you know, I don't expect a fatal failure to happen here inside this block. Does that make sense? Watch out for. Okay, so on to the actual like real life example. Double linked list test. So for me, since you guys are templated and I wanted the project to work over multiple types, there's one other thing that you can do where you can have the test templated over the type. And to do that, you have to inherit from test. You make your class be templated here. And because I also kind of wanted to be template, like have my problems be parameterized over some values as well, these values are going to be held inside these vectors for my particular test cases. Then in double linked test.cpp, I have to use a using statement to define what my types are going to be. In this case, I'm just testing you guys on int and strings. And then you'd say type test suite double linked list test. That's the name of my class back here. And then the test types that you want to instantiate it over. And so it'll create different tests for those different types. So over here, I have a test case that's going to be, then you have for your type test, it's type test instead of test underscore f or test underscore p or just test. The name of the class, name of my test, I'm checking to see if your empty constructor works correctly. So I make a doubly linked list, and then I create another function that would return true or false, more or less, if the doubly linked list and the vector were the same. The same meaning that they were the same size. When you iterated over them forward, you got the same values. When you iterated them over in reverse, you got the same values. And so that function, if you're interested in looking at it, is this mess over here. So one type that you can return instead of returning bool or false is you can return a testing assertion result, right? Either success or fail. And so the first thing I do is I check to see if you guys' vectors and the doubly linked list report that they have the same size. If they don't, I return a failure, and my error message is going to be, hey, these guys have different sizes. Here's the size of the first thing. Here's the size of the second thing. And here's the size of your doubly linked list. Here's the size of your vector. Then I create some iterators that go forward, and then I capture this. I have call another function over here that says values are same. I couldn't think of a good name for this function. And then again, some very nice usage of templates to complain about the types. Type name has to be used here when the compiler can't figure out if it's a type or not, whether it's like a dependent type. For me, because const iterator depends on a doubly linked list of type T, it's a dependent type. I can never remember when types are dependent or not. So if the compiler complains at me that you need to add type name, I put type name there. That's my solution to it. And it will tell you that it's expected, like it's trying to parse this thing as a type, but it's not a type. If you really meant it to be a type, put type name. Like, okay, type name. So I'm checking your forward iterators are the same. If they're not the same, I complain with whatever the result is, and then I test the reverse iterators to see if they're the same. If they're not, I complain, and then I give you back an assertion success if you passed all the ways that you could fail. This other function over here, which takes in, is templated over the linked list iterator type and the vectors iterator type. So we keep going while they both haven't reached the end. And if the values aren't equal, you get a failure that they contained a different value, and I just stop at the first failure. And the it tells you what the value should have been. And then what I do is after I go through all the values, I check to make sure that they're both actually at the end, because maybe you made a mistake in your program and they're both not at the end right now. So if either one of them is not at the end, then we complain. Again, like the iterators denied at the same time despite reporting the same size. Do you guys have any questions? So here's some new things. Look at that template. What does it have as its parameter? It doesn't. So this is called a template specialization, and it's where you're creating a particular instance of a template that should be used if that particular type is provided. So here, if I ask for a doubly linked list test of type int, we're going to make sure to set our constructor args to be 1, 2, 3, 4, 5, 6, right? But only for doubly linked lists of type int, right? This might allow you, if you're providing like a template over some type, if you know that you can do some optimizations for that particular type or that particular object, or if it supports certain features, you can create a specialized version for it so that it can run faster instead of using the generic version. Here, I'm not using it to make it run faster. I'm using it to like set the types, or it's not set the types, set the values of those particular static members that I had, so that I can use them in my test to be able to get some parameterized tests without them actually being parameterized. Then I also have another version for a string, right? So if we have a double linked list test of type string, we're going to make sure that constructor args get set to be Bobcat Sallyman, right? And if you notice, my types that I have are just int and string, so I've actually specified all the types that I could have, so that I can have the values be parameterized as well. For the vector constructor, right? Oops. I call your doubly linked list vector constructor, and then I make sure that both the vector and the doubly linked list have the same values in them. And when we iterate again forwards and backwards, you get the same results. With these type tests, one thing that you can refer to is type param. Type param is the type of the parameter for this particular test or this instantiation of the test. So it might be int the first time and string the second time. It's going to end up being one of these guys that are in here for when I did my type test. Any questions? Is there anything that you're interested in doing in Google Test that we haven't talked about, or things you might want to try? So like a lot of these tests are just like fairly simple. Like I create an empty list, I push a value to the front. Are the values the same? Right? And a lot of testing is kind of just like verifying whether your assumptions are holding true. It's not like super duper complicated things. I just want to make sure that things are happening like I expect them to be happening. And it turns out I actually had mistakes in my code, and writing these tests helped me find some of them. Some more complicated tests might be something like this one, where I do a push front and a push back in the same test to make sure that everything's getting inserted correctly when you're just both putting things on the front and putting things on the end. But I also have tests where I'm just doing things only on the front or only on the end. So it's a really good idea when you're doing testing to make sure your tests are like very, very focused for the functionality that they're looking for and not testing out too many things at once. So here what I do is I create, a doubly linked list that holds your values, and then an answer vector to hold what the answer should be. And then for my push front args, I keep putting them in. So I have an front args iterator equals test fixture : push args.cBegin. So I get iterators to the beginning and to the end of the answer vector, or to the pushback args. And then so we do our front args iter doesn't equal to the end, and our back args iter doesn't equal to the end. Then we insert some answer at the beginning to our vector, because that's the only way to get it to the beginning. And then we push to the front of your doubly linked list. Then we push to the back of both of them. And then we're like, hey, the front and the back better both be equal after we do this. And we keep doing that. If there happen to be leftovers, we keep adding them in. Leftovers might be for the doubly linked list or for the vector. And then we, again, assert that all the values are the same, and then we iterate over them. Everything's working out. This seems like very poorly written code now that I look back at it. But apparently it works, so I'm probably not going to change it. Do you guys have any more questions on Google Test? I encourage you to try using it whenever you have some future project. See whether things are working to your expectations or not, because good testing goes a long way in solving problems now versus solving problems later. Do you guys have any other topics you'd like to talk about today? Do you have any questions on templating? Do you have any questions on iterators? I know we talked about that today. I'll make sure that's all cool. Yeah. Like, you want me to make more examples of templates?
Yeah, because I'm not sure.
I don't think I've ever seen type class. I've only seen type name. I mean, it'd be between using type name or using class.
Yeah, I think so.
So when you declare your template parameter, it's like when you declare your template parameter, this can either be class or type name, doesn't matter which. It's just personal preference. I like type name because I'm like the type name is T, it's not a class. It just specifies a type. But either one will work up here. Say it again. So is your so you want to write begin and you want to write end? Yeah. Yes. So you have to implement begin and end for that iterative for loop to work.
Okay, so it's begin or
just begin and end. So if you look at like the vector class, it has a C begin and C end, and that's for getting constant iterators back. Right, iterators that can't change it. Begin is overloaded, so sometimes it can give you back constant, and sometimes it can give you non-constant iterators depending on the context. Right? If you want to be guaranteed that you're always getting a constant iterator, you would call C begin and C end. Mm-hmm. The for loop, the for loop, the iterative for loop, we'll call begin and end, right? And that's why you generally have to have two different versions of begin and end. One that returns a const iterator, and then one that returns a non-const iterator, so that it works in all circumstances. The piece of code that we wrote today, right? we only did begin and end, right? Ones that return non-constant iterators because we didn't have time to go and write a constant iterator class. So what would happen is if we got a const reference to our vector and we tried to do the iterative for loop, it wouldn't work. It wouldn't compile because we don't have any way of getting back a constant iterator. So if you have the iterator, yeah, we could modify the value back in our example. So if you had a vector, it would be possible to modify the elements in it using only the indices because you can say like do like dot at the index. If you had the iterator, you could also modify the value by just doing star iterator equals the new value. You could, but I'm not sure why, because if you're already iterating through it, you either already have an iterator or you planned on using the for I equals. But yeah, you could get an iterator to a particular spot. Yeah, you get a reference, right? So here we asked for a const auto reference. We wanted a const reference. Right, so what we could do here instead is if we ask for a non-const reference, we could do something like value plus equals 1. And then if we run this, the values will all be 1 larger than what we started them at. You can see it's 2, 3, 4 now on the second line. Because yes, we do have a reference to the object. Do you guys have any other questions about templating or iterators? Any questions about doubly linked lists? Okay, I'll sit around for the next 8 minutes then, if you guys have questions, because I don't have anything else that I wanted to talk about today, and you guys apparently don't have anything you want to talk about. So goodbye.